morning, everyone. Well, it's morning for me. It might be afternoon for you. You are in my barn, which is where we will be doing our lectures from. It's where I have the whiteboard, so luckily I have a whiteboard as it is. So yes, barn lectures, which means that there may be animals running in and out. We might have animals making noise that I might have to stop every once in a while to kind of get them out of the way. But yeah, so we're just making do. So today we are going to start with our first lecture. And our first lecture is just going to be a review. So for some of you, this might be just very easy. If so, fantastic. For some of you, there might be some things that you're like, I got that, and then you're like, oh God, I don't remember how to do that. So you'll want to focus on some of this, and some of it will be just refreshing it. One thing I wanted to say about doing these videos, on YouTube, they are all closed captions, so you can get the captioning down below if you need it, but here's the deal. Because I don't use a script and I talk, you get the ums and the so's and the yeahs. Those come up in the closed captioning. So my suggestion to you is if you don't have to read the closed captioning, don't. Just listen to my voice. The lectures, they make a lot more sense just listening to my voice. The wording on the closed captioning is, I kind of feel bad for people that have to listen to it or have to watch it. Anyway, so let's get to review today. So what we want to review is some algebra. Calculus is kind of a different creature. So before we get into the calculus, we want to make sure that we have some really good basics in our algebra, which is why you had to take prerequisites of algebra in order to get to this point. So I'm going to focus, obviously there was lots of algebra. I'm going to focus on the things from algebra that I know that we are going to use on a daily basis in this class. Okay. There's plenty of more review of algebra to do in the book if you want. Again, I'm focusing on the important things. So when it comes to what we use in calculus, factoring is going to be a big one. Exponents, square roots and cube roots, so I'll just put roots. Logs, lines, and graphs. So if you've got a good understanding of these topics from algebra, it means that calculus is going to be easier. Now, we're going to focus on everything here except the logs. So logarithms, I know not everybody's favorite thing. We do have to do them in this class. But we're going to wait and do them near the end of class. I'm not going to review them now because if I review it now, you're just going to forget it again. So we'll come back and review logs down later on in a couple months when we need it. So right now, let's look at the other things that we need to use in this class. So we are definitely going to deal with polynomials. So factoring is definitely important here. So what I want for you guys to know, I guess I don't need that parenthesis there, is if I were to give you a basic quadratic, x squared minus 4x minus 5, could you factor that? So remember, this is, there's lots of different ways that people were taught this, but this is like unfoiling or factoring into two binomials. And the idea is with the x up front, there's going to be an x at the beginning of each binomial. And then remember how this works. We want two numbers that multiply to be 5. And add or subtract to be 4. Add/subtract. So the two numbers that multiply to be 5, or negative 5 in this case, would be 5 and 1. But we need to get, if we add or subtract, we need to get a negative 4 when we, in this case, subtract, when we subtract these. So if this guy is negative and this guy is positive, then when we do our middle terms, we'll have negative 5x plus x will give us a negative 4x. Okay, Okay, so hopefully, as I said, hopefully this is a bit of review and you remember factoring. Let's look at another one. Let's say I had x squared plus 7x plus 10. Okay, and I want to factor this guy. So remember, x is up front, and these are all the very nice ones where there's not ugly numbers out in front. We don't really have to worry about that too much in our class. We're kind of lucky. So x is out front. Now, two numbers that multiply to be 10, but in some way we'll add or subtract to be 7 would be 5 and 2. And everything is positive here, yes? So we're going to put a positive and a positive. And make sure the 5 plus the 2 gives us the 7, and the 5 times the 2 gives us the 10. All right, one more. X squared plus 12x minus 45. Okay, so I just chose this one because I wanted a number here at the end that has a lot more factors to it. So again, we're going to start with the x up front in each one. Now, when we think of 45, for most of us, the first two numbers that pop into our head are 9 and 5. Okay, maybe not you, but for me, it's 9 and 5. But the problem is with a 9 and a 5, are we going to be able to get a 12? And we're not going to. So our first jumping off point there didn't help us. So now we got to think a little bit more. So what other number goes into 45? 3 and 15. With a 3 and a 15, could we get a 12? So if we put a 3 and a 15, now we need a positive 12. So we need the 15 to be positive, and we need the 3 to be negative. 15 minus 3 gives us 12, and the negative 3 and the positive 15 give us the negative 45. Okay, so factoring. Again, very important in any class after algebra, basically, but always important to remember how to factor. So in the review from chapter 1, there is a lot of factoring. So if you want to practice factoring, it's there for you. Now, the next one that we want to look at is exponents. So we use a lot of exponents in this class. And a lot of the exponents are nice, like a squared, cubed, that type of thing, but we do see some kind of oddball ones. So we need to be kind of up on all of our exponent rules. So just a couple of little rules here. When we have like x squared and then it's raised to the third power like that. So x to an exponent to another exponent like that. Remember that when we put these together, this is going to be multiplication. So x squared cubed is x to the 6th. But if we see it like this, x squared times x cubed, then when we multiply across with the exponents, we add them, don't we? So this guy would be x to the 5th. So first thing that we want to be clear on is making sure that we're good on that, because we are definitely going to do that in this class. We will also see division every once in a while. So let's say that you had x squared over y to the 4th, and then this whole thing squared. Now there are times when we're just going to want to leave the whole thing squared, but there are other times when we want to distribute in that squared to make the problem a little simpler. So remember, in a division, or in a fraction here, this squared is going to come in both to the top and to the bottom. So in its multiplication, so it'll be x to the 4th over y to the 8th. So those are the basic rules that, again, hopefully are in your brain already. Hopefully this is something that's not too new as well, because we're going to use a lot. So when we see negative exponents, so let's say that we had x to the negative 1. X to the negative 1 is not a negative answer. It simply means to take 1 over x. So whenever there's a negative exponent, it's asking you to take the reciprocal. So as another example here, if we have 1 over x to the negative 3, the negative part of that is just telling you to take the reciprocal, flip it over. So this would be x cubed over 1, and you don't need the over 1 part. So this is really important in our class because there are a lot of times when we're going to be given fractions and we do not want the variable in the fraction, or in the denominator, I'm sorry. So it's easy to move the variable to the numerator by changing the sign on it. So another example, this one is one of our most common ones, is that we're going to be given the equation 1, or the term 1 over x squared, but we do not want this guy on the bottom. So it's actually going to be easier for us to deal with a negative exponent than it is to deal with a fraction. So calculus, exponents are our friends, so we don't want the fractions as much, so we're going to do a lot of flipping things around to get rid of the fractions, and the negative exponents are going to come along and we're going to be very, very familiar with them. Okay, so again, basics on the exponents, your exponent rules over there, and then this idea of negative exponents. And we will do lots of practice with that, and again, there's practice in the book, but you know, this is not something that I'm going to be done with today. We're going to do this almost on a daily basis. So the next one we'll look at are roots. So we all should be comfortable with the square root of x at this point. I'm definitely going to use that in this class. Now, the thing is with roots, just like we were doing over here, we don't like to deal with fractions, so we're going to go to negative exponents. Well, we don't really like to deal with roots either, so we're going to write our roots in exponent form. So if you remember, the square root of x can be written as x to the 1/2 power. So remember that roots are represented as 1/2 powers. Cube root would be the 1/3 power. Okay, so if we see the cube root of x, that would be x to the 1/3 power. Again, exponents in this class are our friends, roots not so much, so we want to write things in their exponent form. Then it's easy to deal with. I know it's a fraction, but it's still not that bad, okay? It's better than trying to deal with it in this form. So then let's look at one a little bit trickier here. So let's say we had x to the 4/3. So the fact that there is a 4/3 means that we're looking at a cube root here. But the 4 itself is just a regular exponent. So this, we know that there's going to be a cube root because of that guy. And then underneath the cube root, we would just have x to the 4th. So when you see an exponent that has not just a 1 in the numerator, but another number in the numerator, you can think about that as two pieces. You don't have to think about it as one piece. Think about it as raising something to the 4th power and that as the cube root. And that'll make your life easier. Okay, so again, it's all about exponents. It's all about exponents here. So let's say that I gave you this guy, 1 over the square root of x to the 7th. Now, with what we've been saying, we don't want fractions and we don't want roots. They are not going to be easy with the calculus. Exponents are our go-to. So this is definitely not going to be something we want to deal with. So we can start by rewriting the root. Now here's the 7th, so we're still going to have x to the 7th, but the square root is going to make that 7/2. Okay, so we have 1 over x to the 7/2. I know it looks ugly, it's really not that bad, but it's still in the denominator of a fraction. So if we want to bring it to the top, then what we need to do is slap a negative on here. Don't do anything with the fraction itself, just make it negative. So x to the negative 7/2. And in calculus, that's going to be a lot easier to work with than that. So that's why we're going to focus on doing that. All right, so again, exponents and roots, the idea is to get very comfortable with their negative exponents and fraction exponents. Get very comfortable with that, and that will make learning the calculus part of this that much easier. Now, like I said, we're going to skip logs for right now, so we're going to move on to lines. Now, lines play a major part in calculus. Okay, you're going to see that as we get into the first couple calculus lectures. Lines are very important. So we need to remember some of our basic line information and be able to write the equation of a line. So let's go with lines here. Now, when you write the equation of a line, your answer, okay, the answer, when you give me an answer, it should always be in slope-intercept form. So when you give me a line as an answer, it should be in y equals mx plus b. I don't want it in any other weirdo form. I want it in this form. Okay, so sorry, my notes are not as clear as I thought they were. Okay, so let's say though, we're not always going to be given our lines in mx plus b form. Remember, m stands for the slope and b is the y-intercept. So let's say that they said, given m equals 3 and a point 2, 4, find the equation of the line. Okay, so instead of giving us the equation of the line to start with, a lot of times we're going to be finding the slope ourselves, and then someone will have given us a point normally, but we're going to be finding the slope, and then we need to write the equation of a line. So when you have the line, or sorry, the slope and a point, the formula that we use is not this guy. The formula we use looks like this. Y minus y sub 1 equals m times x minus x sub 1. So to make the algebra easy, we're just going to plug in the pieces where we need them. So this is our go-to formula when it comes to writing lines. So remember that we got the x, y here, and we're going to put those points in, or those numbers in right here for x1 and y1. So we're going to have y minus 4 equals m, which is 3, and then x minus 2. Okay, so this is where I'm talking about, I don't want to see your line in this form as an answer. That's not clear enough for me. So what we want to do is distribute in. So we'll have 3x minus 6 on this side, and then we'll add the 4 to both sides. So y equals 3x minus 2. So you start with this form, but then work it out and give it to me back in y equals mx plus b. The nice thing about this is we can look at that real simply and see that the slope is 3 and the y-intercept is -2. You can almost visualize a graph without even drawing it. We will draw it, but without even drawing it, if it's in this form, it's easy for us to get an idea of what's going on. So let's say we do want to draw it. We start with our y-intercept, which is at -2. And then our slope is 3, or 3 over 1. So we're going to go up 3 and over 1. So up 3, 1, 2, 3, over 1. So there is our second point. And then my lines are not great. They don't need to be great. Just do the best you can. So y equals mx plus b form, writing the equation of a line and drawing the line itself. So let's look at another one here. Find the equation of a line going through -3, 7 with a slope of -1/4. So we just want to do another example, and in this example I'm giving you fractions, so we're throwing in some fractions there, some negative numbers. So I just want you to get familiar with dealing with the fractions because they're going to pop up, believe me. And unless we're doing a word problem, if we're given a fraction in the problem like this, I do not want you to write that as 0.25. It's fraction form. Word problems come in decimal form, that's fine. Doing just math problems, fraction form. So we're going to leave it just the way it is. So again, we've got the slope and we've got the point. So we can go with our y minus y sub 1. So our y this time is 7. So we'll go y minus 7 equals slope -1/4. And then x minus our x, which is actually going to turn that into a plus, isn't it? Right? X minus -3. Okay, now when we distribute through here, the fraction is not disappearing. So we have y minus 7 equals -1/4 x minus 3/4. Okay. Now we have to add 7. But on this side, I'm not going to add 7 because I want it to be in fourths. Everything else over here is in fourths. So 7 written as fourths would be 28/4, right? 28 divided by 4 is 7. So I'm adding 7, but I'm adding it as 28/4. So we have y equals -1/4 x, and then that will be plus 25/4. Okay. Okay. So using this equation here to get to the y equals mx plus b form, that's going to be important. We're going to do that a number of times, and we want to make sure that we're good on that so that that step of the problem is easy and we can focus on the calculus part of the problem. Okay? So if you need to practice a couple lines, practice a couple lines. Then the last thing on our review here is graphs. So we just did a line, so let's look at some other graphs. So lines, yes, lines are important, but some of our basic graphs are the guys that are nonlinear basic graphs. And you know, I know you have graphing calculators, and so if there's something that you need a graph of, you could figure it out with your graphing calculator. But the idea behind these basic graphs is that as we're talking about something, as I'm talking about something in here, and I say to you x squared, I don't want you to have to think about what x squared looks like. When I say x squared, I want immediately for a parabola to pop into your head. Okay, now yes, you could go get your calculator and plug it in, or you could plot points and figure it out, but that's not what we're looking for here. We want things to be faster so we can focus on the calculus. Okay, so we're going to go through some basics. The first one, we're going to use our f of x notation, is f of x equals x. So this is just our most basic diagonal line. Okay. A slope of just 1/1, so the most basic diagonal line. So we want to be comfortable with that one. Now, the next one I said was f of x equals x squared. And when you see x squared, what should pop into your head is a parabola. And we're just sketching here, so notice like there's a little bump there. It's not a big deal. It's just what should pop into your head. In this class, the graph itself is not super important to us. It's just that we have the visual of the graph, what the graph looks like. Okay, so here we have that parabola. Now, another one that we commonly see is f of x equals x cubed. Okay, so x cubed does show up a lot. So x cubed looks like this guy. I call that the squiggle, but hey, whatever. So notice, because x squared means everything's always going to be positive, that the parabola is positive, but x cubed allows there for to be negative answers, so instead of a parabola, you have the one curve going down, the other curve going up. Okay, so we got that squiggle going on there. Alrighty, the next one would be the square root of x. Okay. And the square root of x looks like that, kind of an arc. Now, the thing about the square root of x that is different from the other ones we put on the board so far is this is the first one with a limited domain. Okay, so limited domain. Now remember, domain was the x values. Domain is what values you can plug in there. And we see that in the graph that there are no negatives, are there? So the x-axis going this way, there's nothing over here. Because when you plug in like -4 in there, we go to imaginaries, right? And luckily this is business calc, we don't have to deal with imaginary numbers, woohoo! So that doesn't exist. So we want to make sure that we're always looking at the positive side of it. So it's a positive arc going on there. And then one more that we don't use quite as often in algebra. I know you learned it, but it's not one of our basic go-tos, but I want you to kind of put it in the old memory bank, is f of x equals 1 over x. So we are going to see, even though we don't like fractions in this class, we are going to see fractions in this class. So when we get that rational function of 1 over x, we need to remember what this guy looks like. So 1 over x looks like this. So it's kind of like two arcs kind of curving in there. And the thing to remember is that there is a vertical asymptote at the y-axis and a horizontal asymptote at the x-axis. So remember that an asymptote is a line in this case, okay, that the graph is going to approach. Okay, so this arc that's coming down here, it's going to get closer and closer and closer to the y-axis, but it's never actually going to touch it. Okay, closer and closer and closer, but never actually touch it. So as we head towards infinity, that you're getting closer to those asymptotes. Okay, and asymptotes are going to be important to us in this class, which means that this graph is an important graph to us because it has the asymptote. So when we want to talk about asymptotes, this is the guy that I fall back on. Okay, this one has the limited domain, but it doesn't have an asymptote. So that's what makes this guy special. All right, now again, notice I didn't plot any points. I don't know if the graphs are perfectly to scale. Actually, I know they're not perfectly to scale because I just drew sketches, but that's what we're talking about in this section. When I want you to review your graphs, what I want you to do is just be able to look at it and kind of know what the basic equation is. I don't need you to know, like, what 5 points are or anything like that. Okay? Now, there is one other thing on the graphs here that we want to look at. Hold on one second. Just checking to make sure everything was in focus. Okay, so the last thing we want to look at here are piecewise graphs. And again, hopefully you saw this in algebra. Some of you may have seen more of it. Some of you may not have seen much of it. Just kind of depends on what book you were learning and out of and what teacher you had. But piecewise graphs are graphs that use two or more parts and kind of put them together, kind of like a Frankenstein graph, okay? So as an example here, I'm gonna draw the graph first and then we'll talk about what it looks like. So I might give you something that looks like this. So what I want you to notice is we've got what looks like the start of a parabola going on here, but did it go with its parabola form on the other side of the y-axis? It didn't. On the other side of the y-axis, all of a sudden we've got that arc. So what we need to see is that this isn't a beautiful, smooth graph. There's something weird going on here. So on this side, we're looking at x squared. But on this side, we're looking at the square root of x. So this is two different pieces making one graph, okay? So if we want to write the equation here, we can say f of x equals, and then we use a squiggly bracket because there's going to be more than one thing going on here. So we're going to say the function is x squared if x is less than 0, right? If x is less than 0, then we're using x squared. But when x is greater than 0, on this side of the axis, we're not using x squared, are we? We're using the square root of x if x is greater than or equal to 0. Okay. Now, one of them has to include the equal, and since they both met at the same point on this one, we could have put the equal here, or we could have put the equal there. It really doesn't matter. Okay, so let me give you another one here. So this time I'm going to give you the equation, and then we will go ahead and draw the graph. So let's say that g of x equals x plus 2 if x is less than 1, and negative 2x minus 1 if x is greater than or equal to 1. So this one's going to be a little bit trickier than the one we just did here, because the place where the break happens on this one, the place where they came together was at the axis, but on the one I've got here, the place where they come together is at 1. So what I'm going to do is I'm going to draw just a dashed line. This is just to remind me that on this side we're dealing with one graph, and on this side we're dealing with the other graph, okay? So when we're on the left-hand side, the less than side, we're going to be using the graph x plus 2. Now, x plus 2 is just a basic line, right? Y equals x plus 2. So that means that we would start at 2, and then our slope is just 1 over 1. So we would go up 1 and over 1, which would put us right here on the dashed line. So, but the thing is, we're not including that, right, because it's just strictly less than. I'm going to kind of put an open circle there just to kind of give us a reference point. Now, we could also go down 1 and backwards 1, right? So up 1, over 1, or down 1, backwards 1. And then we see that we have a line that looks like that. But notice how I didn't draw the line over here. Okay? So because on this side of the graph, we're using this line down here. So this line includes the 1. So this gives an open, but when we go to do this one, we're going to use a closed circle. So the way we do this is we figure out what would we get if we plug in 1 into the problem. So if we plug in 1 in there, we'll get negative 2 times 1 minus 1. So that will give us negative 3, which means that at the break, okay, where the two graphs differ, we're going to have a point at negative 3. So if we plug in the 1, we get negative 3. Now from here, we can use our slope, which is negative 2. So we're going to go down 2 and over 1. So down 2 and over 1, which would be about there. And then we've got another line going down this way. Okay, so here we have a piecewise function that is two lines totally different lines, different slopes, everything's different about them. One side we have this decreasing, or well, I mean actually it's increasing there, but one side we've got this guy, the other side we've got a negative slope going on there. They don't even meet up, do they? But they don't have to, okay? So piecewise functions, they don't have to meet up. That one was nice that it met up. They don't have to meet up. They can be very, very ugly. So another one we might see might look like this. Let's say we've got f of x equals, let's go x cubed, oops, I forgot my squiggly bracket, x cubed for x not equal to 1 and 3 for x equal to 1. Okay, so this is another common piecewise function that we are given. So on this one, what it looks like is we've got like a basic function, and then we got this other 3 thing going on. So what this is saying is that this graph is almost always x cubed. So remembering, we can say, oh, we've got our squiggle going on. Okay. Almost always we've got our squiggle going on. But this says that this is x cubed for x not equal to 1. So if this was 1 right here, it means it's x cubed for everything except that point. So x not equal to 1. So we've got the squiggle, but not at 1. At 1, the graph bumps up to the point 3. So 1, 2, 3, which means we're going to have just a single point like this. Okay, so we end up with this, happens quite a bit, not in business applications, but when we're doing some math here, is that we've got actually it does happen in business applications, but we've got a point that does not follow the line. Something weird is happening at 1, and so we've got this nice curve and then boink, and then it comes right back down to the curve. So this definitely can show up, and that's how you would write that. So there's a hole in the curve where the point has gone somewhere else. Okay, so piecewise functions, those might be the trickiest of the things we've reviewed here. So again, there's piecewise functions for you to review. We're going to do piecewise functions in the next lecture as well. So I try not to throw anything too ugly at you, but the piecewise functions, we do need them, so you do want to look at them. Okay, now, like I said, on your homework practice sheet from the book, you can review from chapter 1, do the review assignment. You can do as much of that as you want or as little. It does not matter to me. This is strictly for you to figure out how well your algebra is stuck in your head. So please have a look at what review you need to do. Thank you. Bye.